Hey, this is Don from Padlock Technologies again with another video. This is going to be part 3 of BGP EVPN service provider style. This is going to be the last video. So in our latest video that I just did, I did the normal VLAN based EVPN. If you didn't see that video, you don't know anything that I'm talking about, I'll put something over here to that video, which will have a video to the first video I did. So you want to watch this series, all three of them, right, to kind of get a understanding of service provider style BGP EVPN. This one is going to be VLAN aware, and we're going to be doing multi-homed. Now, before we get into the lab, I'm going to go to the whiteboard and explain the multi-home mode because I believe in concept before configuration, right? If you don't understand the concept and you just go to configuration, when it breaks, which it eventually will, you will not know how to fix it because you don't understand the concept. So if you remember anything from this video here, it's concept before configuration. So let's go into the whiteboard. I'm explaining the concept, and then we'll go to the lab and I'll actually demonstrate it. So let's go here. All right, so we had the whiteboard here, and what we are mainly going to talk about is SP, let me make sure this is on white, SP, BGP, EVPN, and then we're going to do multi-home. Multi-home. I know I didn't have that extra M there. So what this is basically, and I'll do it from a horizontal standpoint. So let's say we have PE1 and then we have PE2. All right. And then we have switch or router, but we're going to be using switches here. So we're going to say SWS. And we'll have a connection like this. So now, what this is basically going to do is I can either go to PE1 or PE2. Between here, these two is going to be a port channel that goes between. So you're probably saying to yourself, oh, this looks like MLAG. It is not MLAG. This is the service provider style. Now, if you're doing it on Nexus OS, you're going to have a VPC. Then you're doing MLAG downstream to a switch, but it's the same concept in terms of the designated forwarding rule. So in mp-bgp EVPN, when traffic comes in this design, you can have it coming from this PE or this PE. Now, what is the problem with this? Very simple. Duplicate packets or duplicate frames. And you don't want that to happen downstream because then you can run into, layer 2 problems and stuff like that. So what the designated forwarder rule is, it is going to say, hey, this router here, or this PE here, is actually responsible for forwarding the traffic, and it will drop frames there. Okay, so now you don't have to worry about duplicate frames hitting the switch and then some layer 2 problems happening. This is the same concept on VPC in data centers. If you're doing VPC in data centers with BGP EVPN, same concept. One of the VPC peers is going to be responsible for forwarding the traffic. So let's say we got the cloud over here. This is the service provider network. And then a frame comes in, it hits here. It also hits here, or the packet comes in and hits there. Well, like I said before, PE2 will not be the designated forwarder, and that will not get forwarded out to the switch, but PE1 will forward it out to the switch. Now, in this design, there is something called it Ethernet segment identifier. Now, you will not see this or have to configure this in Nexus OS. You have to configure it in service provider style. When you configure the port channel, you have to configure this thing called the ESI, which is the Ethernet segment identifier. Now you can do it by MAC address, or you can do it by this nine hexadecimal numbers. I'll show you in the lab. I did it with the 9 hexadecimal numbers, not the MAC address style way. And what that does is say, hey, if switch or router 1 and router 2 have the same ESI, they're in the same Ethernet segment, right? On the other side, they're going to have a different Ethernet segment. They're not going to have the same Ethernet segment, and that's going to be the Ethernet segment for the other side, right? And this is where you're going to see your type 4 advertisement in BGP, EVPN, right? So you're going to see the ESI number in type 4, right? Type 3, remember that was on the last video. That was for your bump traffic. Type 2 is your MAC to IP binding. Type 1 is your router advertisement. Type 5 is your external, right? So if you had an external route coming in, it would be seen as a type 5. Again, different from NXOS, same concept, but it looks a little differently in NXOS versus the service provider style, what I'm teaching you. So now that you understand the concept of designated forwarder and why it's needed in the data center style as well, because you don't want this duplicate packet getting sent downstream and causing problems. One VPC pair or one PE is going to be responsible for forwarding the traffic. That's what you need to understand. So now we're going to go into the lab, and I'm actually going to show you what that looks like. All right, so now we're back in the lab here, and let's pull this over. Same, VPN all in one. Shout out to Orhan for, originally creating this. And we are going to focus on, you see where it says EVPN multi-home, and the EVPN multi-home here. This is what we're going to focus on. So BGP EVPN neighborships are already set up. Everything's perfectly fine. What I'm going to show you is the port channel configurations and the VPN EVPN, L2 VPN EVPN instance configuration. So we're going to just focus on 4 because 5, 6, and 7 are going to be pretty much the same, other than the ESI, which is the Ethernet segment identifier. So now if we go in here, we're going to look at the port channel configuration. I think this is port channel 1. So if we look at port channel 1, you see this right here, Ethernet segment or Ethernet segment 6, and then here's the identifier. Right now I'm using type 0, which is the 9-digit style. So I just did AA, BB, CC, DD. You see it. That's all I did. And then redundancy all active. That has to be on there so you can use all active links. And then we have our service instance, which is 6. Same thing you saw on the other one. The encapsulation is untagged, meaning I'm not looking for a .1Q tag, and I'm going to forward CDP, right? But the main important part here is this in the port channel configuration. If you don't have that, you will not see the ESI, right? You won't have an ESI, and then this won't actually work. Now, I think port 3 is a part of this port channel. Now, for this, yes, port 3 is a part of the port channel. So we go here. As you can see, it's part of the port channel. Now, this is channel group 1 on. Very specific. It's not active mode. It's not active, right? So it's not LACP based, right? It's not mode active or anything like that. On the switch side, it's mode on. Now, you could probably use active or active passive, whatever you want to do for LACP, but I just chose to do on for now. That's the link configuration. So now let's look at the L2 EVPN instance configuration. So if we go to show run section L2 VPN, what you want to focus on is right here. So this is VPN, this is VLAN aware. Now remember in the last video, this was VLAN based. This one is VLAN aware, okay? So you have to configure this to get the multi-home to work. If you do VLAN based, it does not work. That's why I wanted to show you VLAN based versus point to point. Now we're looking at VLAN aware. After you configure that, you don't need to configure a route target because that's automatically created. It doesn't configure any of that. Now we have to tie this all together with the bridge domain, just like we did on VLAN base. That's why I said this stuff is pretty simple once you understand like the basic first, then you move up to VLAN base, and you move up to VLAN aware. Once you got VLAN base, everything else is pretty much the same steps, just you're changing from VLAN base to VLAN aware, and you're having the port channel. So now I believe the bridge group is bridge, I think it's 6. Let me see. Yeah. So bridge 6. Now, you notice the difference with this one here. Same member port channel. We're going to use port channel 1. We're going to use the service into 6. But you notice that the EVPN instance has the ether tag of 6, which correlates to, where's that at? Right here. And then we have that ether tag of 6 here. So all that's mapped according. Once you do that, that is it. VLAN wears up. Now you can do multi-home. Now let's look at the BGP table so we can look at the route type 4. Now I'm going to get details of route type 4. I'm not just going to show you the table. So if we just do show BGP, L2 VPN, EVPN, route type 4. If I can stop fat fingering stuff, 4. Here's the 4. Now, if you remember our ESI ended in 112233. Here's our ESI, right? 112233. This is from the other side, which is 332211. And we hear again 112233. And then 332211. So basically, that's the ESI from the other side. Is just I just reversed the last 3. But as you can see, that's our ESI there. And if you want to just verify on the other side here, we'll just look at the port channel. As you can see, same ether segment, the identifier with the last 3 reversed, redundancy all active, and then your service instance with the basic configurations that we did in the last video. And the L2 VPN stuff, if we just go show run L2 VPN, because I'm using ingress replication. So the L2 EVPN replication style ingress or replication type ingress is still there. Router ID loopback 0. So that's been configured since we started this whole thing with BGP EVPN. So now that that is done, if I show you the normal table, to show BGP L2 VPN EVPN, let me scroll all the way down. This is what it looks like without the details. So as you can see, here's our type 4 for our router because I'm on 4. You see, that's 255.255.4, and then dot 6 has the same. So router 6 has the same ESI, so they're technically on the same Ethernet segment. And one of these are going to be the designated forwarder. You can configure who you want to be the designated forwarder, but that's just pointless. Just let them pick whoever was going to be the designated forwarder. You don't need to get that stupid with it where you're like, I'm going to, 100% say this router has to be the designated forwarder. You don't have to do that. That'd be wasting your time. And then you see router 5 has a different ESI, and then router 7 has the same ESI. So they're on their own Ethernet segment. So now that that's all said and done, let's look at from the CE switch side. So we should have an ether channel. You know what? Let me expand this a little bit so you can see it. Ether. If you want to look at your port channels, it's show ether channel summary. So you see I have a routed RU. If it was SU, that would be layer 2. If it was RU, it's layer 3 because I'm actually doing a routed port channel. As you can see, the port channel is up. If we go to that port channel, again, routed. That's why there's no switch port there, and that's why you see RU. And then I'm doing OSPF on there, and I'm doing OSPF network point to point because I don't want to have a DR BDR election. I don't need it for point to point. It's kind of pointless to do that, right? So now, if EVPN is working as it should, we should have an OSPF neighborship. We should have some OSPF routes. So let's see if we got a neighbor here. We do have a neighbor. So we have a neighbor from the other side because I'm on S2. So 10.6.255.1 is on the other side. All right. And then if we look at our database, we have our router, right? We have our this is, LSA type 1, router LSA. And as you can see, we're doing IPv4. So we have a router LSA here. And all you see is mine and on the other side. Now, if we want to go into a little bit of detail, router, let me say self-originate. If you want to see self-originate, meaning what's in the LSA that I'm actually originating, As you can see, we have our stub network. We have a point-to-point network here. And then we have another stub network. And if you know how to read the OSPF database, you should know everything that you're looking at here, right? You know everything we're looking at here. This is the loopback. This is the point-to-point link that's going through. All right. So now we do show IP route, OSPF. We see the loopback on the other side. That's what we see. So now, last but not least, we are going to try to ping the other side. So we're going to ping 10.6.255.1 source. My loopback, and as you can see, EVPN is working with multi-home, and I'm probably either using one or not router 4 or router 6. Let's see if we trace route and see where it goes. Trace route 5 oh, it should be 6, sorry. 6.255 1 am I tripping here? Let's see what goes up. Now, I did not suppress TTL decrement, right, with the no MPLS IP TTL or IT propagate TTL command. So we should see. Now, depending on the first label, I can tell you exactly where. No, actually, this is EVPN, so we shouldn't even see that. Yep. You're not going to see it because it's a layer 2 VPN, so you're not actually going to see a label. Because, again, we're not doing appearance style. Remember, overlay is layer 2. Peering is layer 3. Since we're doing an overlay VPN, you're just going through a tunnel that's it looks like the routers are directly, our switches are directly connected to each other. So you shouldn't be seeing labels. And if we do show CDP neighbor, I don't know if I'm running CDP. Probably not running CDP on here. Let me look. Let's see if I'm running CDP, which will take forever to run actually. I'll just turn that on real quick. You know, CDP takes 30 seconds. So that's 30 minutes. Yeah, right. 30 seconds. So that may or may not take forever to run. Yeah, that's not going to show up anytime soon because I just turned it on. So let's see here. It's going to take a little while for it to come up because I just turned on CDP. But regardless of that, that is EVPN BGP or BGP EVPN multi-home service provider style. I know that was a lot to chew. It is very important that you understand the designated forwarding concept because whether you're doing it on the service provider side or at the data center level with VPC with a fabric, if you don't understand, hey, why can I not ping or why is the pings going out this switch versus the other switch, it's because it's not the designated forwarder. If you're doing a multi-site deployment with back-to-back VPC, meaning you're connecting the VPCs on both sides together, one of them is going to be the designated forwarder. So you're going to have to configure it a certain way. You even have to cable it up a certain way for it to work correctly, right? Now, most people, they don't do back-to-back VPC or in the multi-site design, they don't do VPC to VPC design because it does have some quirkiness to it. So this is Don from Padlock Technologies. If you like this video, don't forget to share, comment, like, and subscribe to the channel, man. Like, bring people in. This is some cool stuff. I like doing this stuff. So the more people you bring in, the more people learn. Eventually, I can have a bunch of people that know as much as me out there and making the networking community bigger and better. No hoarding information, stuff like that. That's a lot of stuff that I dealt through when I was coming up in the game, but I'm not trying to hoard information for you guys. Again, if you like this video, go ahead, subscribe, man, bring people in. Hope you enjoyed it. Thank you, and have a nice day.